34 squared is going to give us 1156 plus 32 squared, which is 1024. That's going to give us the area C squared. So the area C squared works out to be 2,100 and it looks like 80. Okay, so finding the side length C, we square root. We end up with square root 2180. So from this we need to find perfect square factors. So we need to factor this. So if I divide that by 4, I'm going to end up with, it looks like 500. And dividing 180 by 4 looks like 545. Okay, so we can see if there's any more perfect square factors in here by factoring out 545. So dividing that by 5, I get 109. And we can be pretty confident that there's no perfect square factors in 109. So looking at this, the only perfect square factor we're going to pull out of this is going to be the square root of 4. So we end up with 2 on the outside and 109 times 5 or 545 on the inside. For this last one here, we're going to do the same thing. So our longest side is C. So we're going to take the area 5 squared plus the other area 6 squared and get our biggest area C squared. So we get 25 squares plus 36 squares equaling C squared. So C squared is going to be 61. We want to take that area of 61 and find the side length, so we're going to square root. So we get square root 61. Now we cannot make this into a mixed radical because there are no perfect square factors in 61. So we're going to leave it like that. So to order and compare radicals, it's much easier to do it when we have an entire radical. So what we want to do is be able to take the mixed radicals and make them into entire radicals, and then we can compare these with each other. So square root 208, we're going to compare that to 5 root 50. So we need to convert 5 root 50 into an entire radical. So this is going to end up being the square root of, with 2 on the outside, we need to square it to bring it to the inside. So we get 4 times 50, which is 200. Same thing here. The 7 on the outside needs to be squared and put on the inside. So we end up with 49 on the inside times 4. This works out to 196. Root 360 we can just leave as is. 5 root 9. The 5 on the outside we square to breaking on the inside. And so we get 25 times 9. That works out to be 225. Okay, so then once we have these in the entire radicals, I'm just going to highlight these. We have root 208, root 200, root 196, and root 225. We can say that the root 196 is going to be the smallest side length. Okay, again, the square root 196 represents the side length of an area 196. Well, that's the smallest of these squares, so that must give us the shortest side length. The next smallest square is 200, so that's going to give us the square root of that, or the side length is going to be a little bit bigger than square root 196. And so on. So the next one will be 208 square root. And the last one's going to be, the biggest, is going to be 225 square root, which is actually a whole number of 15. So to explain how we can compare radicals using technology, all we have to do is we have to just punch these in our calculator. We'll just find the decimal value. But we can do it without technology by comparing the entire radicals.